All right, this is going to be my video presentation for the Lab 1 in MEC 150 DC circuits. Real briefly, I want to point out some hardware changes I made to the lab. The lab calls for one 600 ohm resistor to be placed here and two 300 ohm resistors to be placed here. I have neither 300 nor 600 ohm resistors. So to replace the 600, I put two 330 ohm resistors in series here, and then I replaced the 300 ohm resistors with 330 ohm resistors here. Here I have my power supply that goes into my generic Arduino. I got my my positive voltage output at the 5 volt, and then my ground cable plugged into my negative terminal here on my breadboard, and the positive plugged in there. Our circuit begins here at our first push button, and when the first push button is pressed, it will close this circuit here, the 600 ohm, or in my case, two 330 ohm resistors, right there. And as we see, the light turns on. So when this circuit is completed, and if we calculate the resistance, just using theoretical resistance calculations, we should get the 330 plus 330, or 660 ohms. But when you check it with your multi-tool, you end up actually getting 557 ohms. So that's a pretty close accurate representation of what we should expect. So next, after the first button is pressed, we come over here, we see this circuit is completed. Press button 2 is in series with press button 1, and it closes a parallel circuit with these resistors here. So as we see, pressing button 2 by itself doesn't complete the circuit. You need press button 1 to be pressed, and then press button 2 completes the parallel circuit, and it makes the LED turn brighter. The reason it turns brighter is when taking resistance in parallel, you take the inverse of the total resistance, and that is equal to the sum of the inverses of all the resistors. So in this case, these resistors are in series, so they're added to get that total resistance, 1 over that. These resistors are in series, so they are added, and then 1 over that, since we're in parallel. If you calculate the math out, you should end up with a theoretical total of 330 ohms. When you check it with your multi-tool, what I ended up with is an actual resistance of 329 ohms. So again, pretty close to what we were to expect. Lastly, we're going to complete the short circuit with the third press button. The third press button, if we come over here, is in series with all the other press buttons, but what it does is when this parallel circuit is closed, it bypasses this resistor. So when we come over here, press 1, 2, 3, we end up with an even brighter still LED. And again, that's because when we do our math, we are going to end up with a theoretical resistance of 220 ohms, which is less. In each case, we have less resistance, theoretically, hence bright, bright, and brighter. Bright, brighter, and brightest. And when I hooked it up to my multi-tool, I got a actual resistance of 220 ohms. So that one was pretty much spot on. So that's basically the video explanation for Lab 1. And yeah, I'll submit this to YouTube once I figure out how to do that. How do I stop this?